The circle is arguably the most fundamental shape in our universe. It appears everywhere, from planetary orbits to everyday objects like wheels. Today, we'll explore the fascinating relationship between a circle's measurements and the mathematical constant known as pi. Every circle has key measurements that define it. One of these is the diameter, a straight line passing through the center from one side to the opposite side. The diameter represents the widest distance across the circle. Another important measurement is the circumference, the distance all the way around the edge of the circle. If you were to place a string around the entire circle and then measure that string's length, you'd be measuring the circumference. Now here's where things get interesting. Thousands of years ago, mathematicians discovered something remarkable. If you divide the circumference of any circle by its diameter, you always get the same number. This special number is pi, approximately equal to 3.14, though its decimal digits continue infinitely without repeating. This might seem like a simple coincidence, but it's actually a fundamental property of all circles. Let's verify this by looking at circles of different sizes to see if this relationship holds true. Here we have two circles of different sizes. Let's first measure their diameters. Our small circle has a radius of 1 unit, so its diameter is 2 units. Remember, the diameter is always twice the radius. Our large circle has a radius of 2.5 units, which means its diameter is 5 units. Notice how the diameter is simply twice the radius. This relationship is true for every circle. Now let's find the circumference of each circle. For the small circle, we can calculate the circumference using the formula c equals pi times d, where d is the diameter. With a diameter of 2, the circumference is approximately 6.28 units. For our large circle with a diameter of 5 units, the circumference is approximately 15.71 units. Again, we're using the same formula, c equals pi times d. To better visualize this relationship, let's organize these measurements in a table and calculate the ratio of circumference to diameter for each circle. This will show us whether pi truly remains constant regardless of the circle size. Look at our results. For the small circle, when we divide the circumference 6.28 by the diameter 2, we get 3.14. For the large circle, dividing 15.71 by 5 also gives us 3.14. This is pi. The ratio is exactly the same for both circles, despite their different sizes. This remarkable consistency demonstrates why pi is a mathematical constant. No matter how large or small the circle,